Hello everyone! So in today's video, we are going to talk about calculus and the big controversy behind it. So first, what is calculus?
Calculus is the mathematical study of change. It can be used for many things, such as the velocity at which an object moves, how it accelerates for optimization, like maximizing the volume of a container or minimizing the cost of production of a product. It can also be used to calculate the area under a curve or to find the volume of a solid with atypical cross sections. Calculus has two main branches, differential calculus and integral calculus, that are at the same time opposite and complementary to each other. Just as addition is to subtraction, differential calculus is to integral calculus.
Unlike the major mathematical discoveries, calculus isn't inherited from ancient Greece or the Babylonians. Indeed, it was discovered separately during the 17th century by two of the greatest worldwide scientists, Sir Isaac Newton and Gottfried Leibniz.
Let's learn a little bit more about these two mathematicians.
Sir Isaac Newton was an English physicist, mathematician, astronomer, and natural philosopher. During the middle of the 1660s, he developed the concept of calculus simply out of necessity in order to have the tools he needed to solve problems in his Mathematical Principles of Natural Philosophy, Book 1, published in 1687. He pursued his research on calculus and wrote many papers that he wouldn't publish until the 18th century. The word was spread out for scientists all over Europe that he worked on calculus and that he used the techniques of calculus in his scientific work.
Newton's approach consisted in finding the tangent of a polynomial curve at a specific point in order to measure the rate of change of the function at that point. For a linear function, we could find the steepness thanks to the slope, the gradient, by dividing the difference of the y-coordinates of 2 points on a line by the difference of the x-coordinates of those same 2 points. But to find the steepness of a polynomial function, we cannot use the same formula. The process is different.
To better visualize the process, let's modelize the function f of x equals to 3x cubed plus 2x squared minus 4x. We place a point A whose coordinates are minus 1.32 in order to find the tangent of the curve at the point A. We have to choose a close point to A, let's call it B, whose coordinates are minus 1.2 and 2.5, and we find the slope of that line. To get a more precise idea of the gradient of the tangent, we move the point B closer and closer to the point A, and we see that the value of the slope of the tangent tends towards 6. We can assume that the approximate gradient of this tangent at the point A is 6, and this value corresponds to the derivative of A. We can find the gradient of the tangent at all points of the curve by using the derivative function. This process is called differentiation, which is the study of the derivative of a function and how it changes when its input changes. The derivative noted at any point equals the slope of the tangent line of the function's graph. Basically, the derivative of a function determines the best linear approximation.
The other famous scientist that worked on calculus was Leibniz. Gottfried Wilhelm Leibniz was a German mathematician who is probably most well known for inventing the integral calculus somewhere in the middle of the 1670s. He conceived of the idea in about 1674 and then published the ideas in 1684, 10 years later. His paper on calculus was called A New Method for Maxima and Minima, as well tangents, which is not obstructed by the fractional or irrational quantities.
His approach to calculus was more of a mathematical approach. He studied integration. He tried to find the area under a curve, meaning the area of the section in between a function and the x-axis.
Let's take an example. We can see here that we can easily calculate the area of these shapes because the distance between opposite sides is fixed. We simply have to use formulas. But when the value, such as the height of a figure, is changing from each point to the next, as we can see here, we do not have a specific formula that gives us this area.
We can approximate this area by drawing rectangles. In order to get a more accurate approximation, we simply make them narrower and narrower still to more closely follow the curvature.
Leibniz's work is still present in our studies almost every time we use calculus. He was the first to introduce the symbols dy and dx to represent infinitely small increments of x and y, as well as the notation for the integral, which is still found to be the more effective calculus notation to this day.
But whether differential or integral calculus, both concepts involve the idea that we can do something infinitely many times and get a finite answer. They both deal with the notion of limit, with things that are infinitely small or infinitely close together.
We are now going to see why the controversy between Newton and Leibniz about calculus isn't a controversy anymore. As Newton and Leibniz both worked on the same notion, the question of the true creator of calculus has raised many arguments. Unlike Newton's claims, Europe first heard about calculus from Leibniz in 1684, because Newton kept all of his work private until 1693. The English scientist also accused Leibniz of plagiarism of his non-published writings. But Leibniz actually discovered integral calculus over a decade before Newton's Principia and also created the mathematical notation that we use nowadays.
At that time, salons were created where philosophers would debate ideas, called scientific societies. The first and most famous one is the Royal Society of London, who guided public opinion over scientific discoveries. First, when the Royal Society was asked to educate between the rival claims of the two men over the development of the theory of calculus, they gave credit for the first discovery to Newton and credit for the first publication to Leibniz. But in 1703, Newton was elected president of the Royal Society, which led to many accusations of plagiarism towards Leibniz and a full recognition towards Newton. However, Leibniz always stated that he independently worked on calculus with no access to Newton's notes over the subject. It would be fair to say that Newton and Leibniz both contributed independently and in two completely different ways to calculus. They used different approaches. Newton had more of a physical approach. He used calculus in order to solve a physical issue he encountered,
while Leibniz's approach was more of a mathematical approach. There is not a single creator of calculus, just as the controversy isn't a controversy anymore. Thank you so much for watching. We hope that you like this video. Do not hesitate to go and check our Matheso channel.